Today we talk about CPU scheduling in OS system. Introduction of CPU scheduling. The CPU scheduling is the process to select which the process will be executed next maximum CPU utilization. Goals: fair process to executed, maximum CPU efficiency. Needed CPU scheduling. The multi-programming system, multi-processor to complete the CPU time. Advantages: efficient process to executed, improve the response time. CPU scheduler. CPU scheduler is select the process from ready for executing. Types: short time scheduler, long time scheduler, medium term scheduler. Scheduler criteria. Key criteria for evaluating scheduling algorithm: CPU utilization, throughput, waiting time, response time. Primitive and non-primitive scheduling. Primitive scheduling, it is allow interrupted running process. Non-primitive scheduling, the running process complete before switching. Example: round robin primitives. First come first server is non-primitives. Next, first come first server, this process executed the order there arrived. Advantages: simple and easy to implement. Disorder: poor response the time, suffering for this effective. Shortest job, the next, the process with the shortest executing time is scheduled first. Reduce the average wait time. Disadvantages: difficult for predict job length, can lead the shortest execution. Priority scheduling. Each process assign the priorities, the highest priority process to executed first. Types: primitive priority scheduling, non-primitive priority scheduling. Round robin scheduling. Each process get fixed time slice, time quadrant before switching. Benefit: ensure fearless, reducing the fixed time. Drawbacks: high context switch overhead. Multi-level queue scheduling. The process divided into different priority queues. Example: system, interactive, batch. Each quiz has own scheduling policy. Next, multi-feedback queue scheduling. Similar multi-level queue scheduling but allow the process the movement between queue before on the behavior. Next, shortest running time first. SRTF. The primitive version SJN, it scheduled that process which the shortest remainder execution time. Advantages: improve the response time. Disadvantage: can lead the longer process. Fair share scheduling. Fair share scheduling ensure that CPU resource are shared fairly among your or process. Next, real-time CPU scheduling used in critical system like embedded system and industrial automations. Types: hard real-time scheduling, soft real-time scheduling. Load balancing CPU scheduling. Distributed workload across the multiple CPU to improve the efficiency. Method: static load balancing, dynamic load balancing. Next, context switching. The process of switching from one process to another process. Cause process to scheduling, interrupt handling. Overhead: involves saving and restoring the process states. Next, comparison of CPU scheduling algorithm. It is comparing the two objects: algorithm, primitives, average waiting time, complexity, so that it is used for that. Next, CPU scheduling of multi-core processor. The modern CPU use advanced scheduling of the optimized performance technique, load balancing, thread scheduling, parallel executing. Next, challenges of CPU scheduling: avoiding stagnation, minimizing context switching, adopting the multi-core architectures, balancing efficiency and fairness. Next, conclusions. This CPU scheduling is crucially for system performance. Understanding the different algorithms to helps in the designing better operating systems for various computing environment to use this process. That's all. Thank you to everyone.